Hey, hello everyone. Welcome to this lecture series on data architecture. Today we are going to discuss about data storages, and specifically we are going to talk about data lake as a storage. So yesterday we discussed about data warehouses. So if you are an architect and going to design a data warehouse, what are the different things and key design considerations, different tech choices that you have is what we discussed yesterday. Today we will discuss about data lake. Somewhere around 2010 onwards, right? When Hadoop became very, very popular, people started building data lakes. Now, why do we need data lake, and are they still relevant in today's world? Okay, let's see that. Okay, let's discuss that in detail. So data warehouses, right? Initially, traditionally, the traditional warehouses was all about structured data, right? What we have seen earlier, it was all about structured data. But with social media, right? Social media feeds, Facebook was very popular that time, and then we started getting a lot of data from um, different social media feeds, right? Not just Facebook, but Twitter as well. And then IoT devices send some data. You have a lot of images. You have um, videos, right? Audio clips. So all these are like unstructured data. So to store all this data, to manage this data, to process all this data, right? We need something called as a data lake. Okay. So what is data lake? So you could store all different types of data. It can be structured data, unstructured data, semi-structured data, right? All this data could be stored in a data lake, right? So when Hadoop became very popular, we used to store it in something called as HDFS, right? Hadoop Distributed File System. So this was the distributed data storage, okay, built on commodity hardware. That is where we used to store it. So a bit about Hadoop, right? Let's talk a bit about Hadoop, right? Hadoop. If you have not worked on Hadoop, just a quick summary, right, of what Hadoop was. So there was a master node or a primary node. These are different types of servers, and then there were multiple data nodes, right? Multiple data nodes. Okay, and what these data node had. Okay, so let's look at this one data node. This would comprise of a compute, okay, memory and storage. Okay, so we are particularly interested in this storage. We are going to talk about this storage in this lecture. So a single data node, right? These are nothing but servers. Okay, if you have seen any servers, you have been to any data centers, you would know these are like there is a rack in a data center. There is a rack, and then you have different servers. Okay, it looks something like this. Like, let's say inside a data centers, you'll have multiple racks, rack one, two, and three, right? One, two, and three, and there will be multiple servers kept within that. Okay, so this data node is this one of the servers. Within that server, you have a compute, memory, and storage. Typically, some of the servers that I had seen, right, they'll have multiple hard disk slots. You can have multiple slots to have your hard disk there. So like, let's say there are 12 slots here. Okay, there are 12 slots here. You can have, let's say, 2 TB to, I think the max like 6 TB disk also. So 12 into 6, right? 6 TB is what you could get as a data storage. Now here, if you remember, I discussed yesterday tightly coupled compute and storage, right? This is what it was, tightly coupled. So if you have done with this, right, like let's say you have data exceeding this like 72 TB. If you have more data, right, almost like 90% is full. So the only way, right, you cannot add more disk here, right, because all the slots are full. You would need another data node. You would need another data node. Now when you would get another data node, it would come with a compute and memory also, though you don't need that, right? You just need the storage. But then because this was tightly coupled, you would have to go for another data node, another compute, another memory. Obviously the pricing would increase because of that, right? So this was the problem with the Hadoop architectures. Okay, which are like, see, that time it was not a problem, but nowadays we prefer having a separate compute and storage, right? Like in case of Snowflake, what we discussed yesterday. So this is how we used to store the data in a data lake. All this data would go on to this storage system. Now this was with HDFS. Now the modern data lakes, right? In today's world also, data lakes are very, very relevant. Okay, let me just in today's world also data lakes are equally important. So what happens in today's world? What we are doing is we are building cloud data lake. Okay, what does that mean? Cloud data lake. That means instead of HDFS, we are using the cloud object storages to store the data, right? Like Amazon S3 is there, ADLS, Gen 2, GCS, right? These are all from different cloud providers. If you are into on-prem, there is something called as main IO, which you can check out. You can build a data lake using this software. So, in today's world, also data lakes are important. It is still relevant. We are building data lakes, but then instead of HDFS, we are using the cloud object storage. Now, if you try to compare this, right, HDFS versus S3 and all, if you try to see that, right, which one you should use. See, nowadays, not many people are using Hadoop until unless you are, you have your legacy applications or you have a lot of data into HDFS. You still want to continue that, you can still implement Hadoop on uh, cloud. Let's say you can take AWS, right, EC2, you can have Hadoop on that, or the best is you can still use EMR, elastic MapReduce, which is an AWS service, and you can use Hadoop there. You can have your data onto HDFS. I've created previously, I think couple of years back. You can check those videos if you are really interested in HDFS versus S3. But the modern way of doing the things are using the cloud object storages. So even today, you can create a data lake and start dumping your data into S3. So how this would work, right? Let's say you have a source system. From there, you will get the data. You'll use something like AWS Glue and put the data into S3, right? This will become your data lake, right? So anything, all the data, right? So in S3, it becomes very straightforward. You just have to create the bucket, okay, and you can start dumping the data. Now generally there is a design for this, right? We can create a raw layer, right, where you are going to keep this data. We'll discuss about these layers, right, the medallion architecture and all in some of the other lectures. Okay, I won't get into those details as of now, but just try to understand, right? You are if you're building a data lake, you have to move the data from the source system, maybe use some ingestion tool like glue as in glue ETL, and put it into your raw layer. And raw layer is nothing but your S3 bucket where all the data would be present. And from there onwards, you can implement all the other stuff, right, to move this data from raw to cleansed, and cleansed to your curated layer and all. As of now, just try to understand why we are building this, why we are using cloud data lakes is so that you can have all your structured data, unstructured data, whatever data is there. Maybe it is coming from RDBMS system, right, IoT devices, Kafka, right, from wherever you are getting this data, SaaS applications, you can just take it, put it into your S3 bucket, and that becomes your data lake. And from there onwards, you can use your data. Now, going back to your Hadoop days, right? So, during the Hadoop days, what we used to do is, right? Um, there were a couple of softwares or tools that were very popular. Was Cloudera, right, and HDP, Hortonworks data platform, HDP. I think both of them are now merged. It's Cloudera. It is known as, I think, CDP. Um, so that time we would take the data from various source systems. There were different tools. Now, why you should be aware of these things, right? I know I said, right, not many companies are using it these days. But as an architect, maybe you might get into a project where you are migrating, right? A lot of projects are there where you are migrating from Cloudera to your, let's say, EMR or Databricks, right? This is a very common use case or very common projects that you will see in your migration journeys, right? So that's where you should be aware of this. So how it used to happen in the Hadoop world is what I'll just try to explain. So if you have data into some RDBMS system, right? So you take this data. There was a tool called Scoop. Okay, in Hadoop, we would connect to RDBMS system, use Scoop and get the data into HDFS. Okay, HDFS. This is your file system. Now, when you're putting the data, there were popular file formats. Okay, which I'm sure you must have heard, like Parquet. Okay, ORC, and the third one was Avro. These are the popular file formats which were used that time. Generally, I had seen most of the implementation using Parquet, where Cloudera, right? Cloudera implementation, mostly they had Parquet. Houghtonworks implementations mainly had ORC. Avro was not used widely, but again, it all depends on what I have worked on which projects. You might have worked on projects where Avro was used a lot. Avro is a row based. Okay, it is very popular for where you have a lot of schema changes coming in. So it had this schema evolution kind of a feature. So those use cases use Avro. Else Parquet and ORC are columnar, and these are very popular. Now in the modern data world, most of the organizations are now using Parquet. It has kind of become a default file format which most of the organizations are using. In fact, you look at Azure today and see the open table format and file format that they support. It's Delta Parquet. We'll talk about the open table formats later when we discuss more about lakehouse and the other things. Okay, so these were the things that and maybe I'll create another video for what is Parquet, why it is faster, how does it store the data. Multiple videos are there available for that. Some really good videos, you can check that out. If not, maybe I'll create that some other time. So during the Hadoop days, yes, we'll take the data from RDMS, scoop it, put it into HDFS, right? This was your raw layer. So if you're migrating this kind of an use case today, what you'll have to do, you'll have to replace this scoop part. Okay, replace this scoop part. You can replace by anything, right? If you are using Databricks, it is just a matter of ingesting this data. You can use Spark to ingest that data. You can use any ETL tools. If you are using Azure ADF, AWS, you can think of using Glue or EMR, right? It all depends what you really want to use, and then you have to bring it into HDFS. And again, the better thing is to use cloud object storage. You can use something like S3 and all, okay? Because why S3? It is, I mean, compared to HDFS, it is more scalable, available, right? You can easily integrate S3 with all other services within AWS. So so this was how the typically ingestion would happen. Now what happens after this, right? What used to happen after HDFS? So after HDFS, right? So let me just move this. So once you have your data, right, from source system, let's say you have done scoop your data into HDFS, we would create Hive tables. Okay, Hive was a very popular tool that time. You would create Hive tables and then run your queries on top of it, right? Queries on top of it. Okay, so Hive has, now Hive is a very popular tool, I would say, or a framework, I would say, which is still very relevant. Whenever you hear about Hive, right, there are three things that you should be aware of. Hive provided a HMS, Hive Metastore, which is still used by many cataloging tools, okay, even in today's world. So Hive Metastore to store the metadata. Second, it is a open table format, okay, like your Delta Lake, Iceberg, and all. It is also an open table format. And third is it's a query engine, right? HQL. So you can write Hive query language. This is HQL. Write Hive queries, and there is an engine behind that. Okay. So it was like if you want to build. So HDFS is your data lake. If you want to build a warehouse kind of a thing on top of this, you can use Hive. So we would, take this data into HDFS, create the Hive tables on top of it, and then use it for queries. Now, what Hive is, right? Hive is just a, um, it's not you have to copy the data from HDFS to Hive. Okay, say HDFS and Hive table. It is that if there is this Parquet file, okay, Parquet file within your HDFS, you just have to create a table on top of it. Okay, so you would say create table ABC and location as, let's say, this file. Okay, this file. So that this is just the metadata layer on top of it, exactly like the Delta Lake or Iceberg, the latest open table format. If you have worked on that, maybe you have worked on Delta Lake, but you have not worked on Hive. You can use this as a reference for that. Okay. So this is how a typical flow during the Hadoop world would look like. Okay. Now instead of Scoop, there were other things also. You could use Spark as well. Okay, you could use Spark to put the data into HDFS, but after that it was Hive to query the data, and then you can query that. Now even before Spark, right? Like if you just go back, there was something called as MapReduce. You could write a program of MapReduce to do anything. In fact, Hive in the backend uses MapReduce only. Okay, the Hive engine in the backend, it creates a MapReduce job, and that is why it is very slow. Yeah, if you try to run a query using Hive, it is very slow. So in the Cloudera world, instead of using Hive here, right, as a query engine, we would still create, put the things on HDFS and all. There was something called as Impala. Okay, Impala as an engine that we used to run it, and it was much faster than Hive. Okay, because it I think it didn't use in the backend. I think it was not using MapReduce, so it was fast. But again, there were various different variations here. You could use Hive with the Spark engine and the backend. There were multiple things. But yeah, this is just for your reference today. If you are going to migrate something from Hadoop, you should be aware of these things. What all things you need to change is this part, whether it's Scoop or Spark, you have to move this. HDFS you move to your S3, and for Hive, right, you can use any other open table format, or you can use, if you are replacing the query engine part, you can replace it with Presto, Trino, or if you're into AWS, you can use Athena, right? Those kind of services. So this is at a high level how a data lake used to look like in the Hadoop world. Now today, if you want to do that, right? Let's say it's not a migration. If you are implementing a new architecture and you want to use a data lake, again, as I mentioned yesterday, uh, most of the organization are now implementing a lake house. Okay, and we'll talk more about that. But let's say you still want to use a data lake kind of an architecture only, then how your jobs would look like: you would have a source system, data you are moving through Spark into S3, and then you are using, like, your Athena to query the data here. Okay, query the data here. So S3 becomes your data lake, so where all the data is being dumped, right? There is no warehouse here, you are not moving the data, right? So this is just a simple data lake implementation where data is coming from source systems, you are ingesting it into a data lake, which is nothing but the cloud object storage. In case of AWS, it is S3, and you are running your Athena queries. But if you see this, what's the limitation? These would be very slow, right? If you just try to query Parquet, right, and then these are just the Parquet files, right? Nothing else. You are just putting the data into STS Parquet files, and you are trying to run it using Athena, which in the backend uses Presto Tino engine, right? And you are trying to query Parquet. So you can try this out. It's going to take a lot of time because there's no open table format on top of it. There is no uh, all those things related to statistics that it's going to maintain. There's no transactions, I mean, the asset support is not there, right? Because you are just using Athena with Parquet. And above all, the main thing which is missing here, right, you cannot do an update. You cannot do an update, right? That is because S3 is your immutable storage. Okay, because it's an immutable storage, you cannot really do an update. So you're going to miss the asset support, you are going to miss the update kind of thing. This is also going to be very slow. So all these limitations, so you can't really practically run BI queries on top of this. Um, so to overcome this kind of things, right, there was a new architecture, or as a, I won't say new architecture, it was an another way of doing the things. Organizations started building both a data lake plus a data warehouse. So there would be S3 plus, let's say, Redshift. Okay, so this is the architecture that organizations started building, and we'll talk more about this tomorrow. Okay, in the next session, maybe I'll also talk about the limitations of data lake in that session a bit more, so that you would understand why we would need a new kind of an architectural pattern here. So far, right, we discussed about two things: data warehouse as a storage, the second is a data lake. The next is a data lake plus a data warehouse, and the fourth would be the lake house. So we are going to discuss all of these. Stay tuned for that. So yeah, that's it for today. And as I mentioned, I've been talking about it. I have some AWS credits to give. If you want to try out anything into AWS, you can just ping me on LinkedIn, and I'll pass on those $20 credits, and you can try this out. Apart from this, if you have any other questions, do put that into comments, or any other topics that you want to discuss. Nothing among this is really scripted. I just jot down few things which I come and talk about in these sessions. But if there is anything specific, we can talk about it. If you have any specific questions and you want to do an one is to one, you can connect with me on Topmate as well. Thank you and have a good weekend.